In this video, we're going to apply what we know about rates to find other amounts that we can use which would have the same unit rate as the situation we were given. We will also use this application of rates to find out how to make various amounts of different types of mixtures. In our first example, Tom has built his very own car. It was a high school project he always wanted to do. It wasn't a very pretty car, but he was proud of it. And his car gets 22 miles to the gallon. How many miles can he travel on 17 gallons? Let's start by writing what we already know. Tom can get 22 miles on 1 gallon of fuel. This is a ratio. It's a rate. In fact, it's a unit rate because its denominator is 1 gallon. We can use that unit rate to find out how far Tom can get on 17 gallons by simply creating a proportion. We know that he wants to travel as far as he can on 17 gallons. We know the amount of fuel. We don't know how many miles he can go. So we're going to call that X. Now at this point, this simply becomes a proportion that we solve using our cross products. We're going to say 17 times 22 and then 1 times our X. 1 times X is, of course, just X. And now 17 times 22 is 374. So in Tom's homemade car, he can get 374 miles on 17 gallons of gas. Let's look at a similar situation with Tom's car, just different circumstances. We still have Tom's homemade car that gets 22 miles to the gallon, and this weekend he's traveling to a college campus to see if he wants to attend there next year as a freshman. That campus is 506 miles away. He needs to know how much money to budget for fuel. So he needs to know how many gallons of fuel it's going to take to travel at 506 miles. So our initial situation is it takes 1 gallon, and in that 1 gallon he can travel 22 miles. So we have this ratio, 22 miles to 1 gallon. And we're going to make an equivalent ratio on the other side so that we'll have a proportion to solve. Our mileage was on top in our first ratio, so we'll put our mileage on top of the second one. He has to go 506 miles. How many gallons will that require? There's our proportion. We're going to find our cross product. One times 506 is easy. That's 506. That's equal to 22x. And now to finish solving this, we'll divide by 22 on both sides so that we get 23 equals x. It will take Tom 23 gallons of fuel to travel that 506 miles to see if he wants to attend that university. Here's an example for you to try on your own. Whenever Samantha cooks brown rice in her rice cooker, she must add 3 cups of water for every 2 cups of rice. How much water does she need for 5 cups of rice? Why don't you press pause now and see if you can solve this on your own? Well, let's see how you did. Here's the rate that we have. We know that it takes 3 cups of water for 2 cups of rice. That's the rate that we're given. Now it's not a unit rate, but it is a rate nonetheless. And Samantha wants to cook 5 cups of rice. She needs to know how much water she needs to add to her rice cooker. And you can see this is the proportion we get. And we are going to do our cross products. So 2x, let me say 2 times x, and 5 times 3 is 15. We divide each side by 2, and we get 7.5 cups of water. So if Samantha wants to cook 5 cups of brown rice in her rice cooker, she would need 7.5 cups of water. Here's another one for you to try on your own. We're going to flip the measurements this time. Samantha's got 5 cups of water. How much rice can she cook with only 5 cups of water? Press pause and see if you can solve this on your own. Let's see how you did. We still have the same rate of 3 cups of water to 2 cups of rice. That hasn't changed. And now we know that she has 5 cups of water. We just need to figure out how many cups of rice she can cook. Just like every other rate we've done, or proportion we've done rather, we are going to do our cross products. And when we do our cross products, we get 2 times 5, and that is 10. And we have 3x on the other side. And when we divide both sides by 3, we get x is 3 1/3. 10/3 as a mixed number would be 3 1/3. So if Samantha has 5 cups of water, she can cook 3 1/3 cups of rice. Our final problem. This one has just a small twist, an extra step involved in it. Professor McGee's magical mystery cleaner will remove any stain. To make a cleaning solution of the miracle cleaner, you mix 125 ounces of water with 3 ounces of concentrate. How much cleaning solution can be created with 1.8 ounces of concentrate? There are 2 steps to solving this problem. The first step is we need to determine how much water to mix with 1.8 ounces of concentrate. Once we have determined that amount, we would add the amount of water to the amount of concentrate, and that would give us the total amount of the solution. Because if we look in our previous set in the rate up above, we have 125 ounces of water with 3 ounces of concentrate. Together, those make 128 ounces of the cleaning solution. So we have to find the amount of water needed for the 1.8 ounces of concentrate, add those 2 things, and it gives us the total amount of the mixture or the cleaning solution. So let's set up our rate. We have 3 ounces of concentrate. I'm going to abbreviate that CON. For 125 ounces of water, that's our rate. Again, not a unit rate, but it's a rate nonetheless. And on the other side, we have 1.8 ounces of concentrate, and we need to determine how much water we can mix with that. We do the cross products, and we get 3x equals 225. We divide each side by 3, and we get x equals 75 ounces of water. But this doesn't solve our final problem, because what we're trying to find out is how much total cleaning solution. We know we have 1.8 ounces of concentrate. Now we add the 75 ounces of the water, and we get a total amount of 76.8 ounces of total cleaning solution. This concludes our short video on how to use rates to determine the amount of the different elements you would use for a mixture, or how to use rates to find other amounts that you would have, say, relating to cooking, the rate or how far a car can travel, etc.